The Arctic Circle is known as a cold, empty tundra where some of the most extreme weather conditions can be found. Even though it has this reputation, though, it actually isn't even the coldest place in the northern hemisphere. But don't let that fool you, because temperatures can reach below -50 degrees Celsius in the tundra. This makes exploration and development difficult in the Arctic. Although, as we will explore in this video, we can see the ways the changing challenges that the Arctic creates can be overcome with mechanical engineering. Beginning with a brief history of the exploration of the Arctic and the devices that helped successful travel. Then, moving into the present-day developments which have allowed for natural resource extraction. Finally, how the changing climate is helping to increase efficiency in natural resource recovery. The Europeans first discovered the Arctic in the Elizabethan era, when sailors looking for the Northwest Passage found ice instead of open waters. Even after its discovery, further exploration of the Arctic didn't continue until the 1800s, when there was a revival in the search for the Northwest Passage. Many expeditions were made, but many failed, with numerous explorers falling to the harsh conditions. The true success of exploration in the Arctic came from the Inuit. The Inuit had survived in the Arctic for generations due to their use of technologies such as the sled and snowshoes. These devices, which made use of reduced friction and an increased area of applied force, allowed the Inuit to navigate the Arctic effectively. These are great examples as to how early mechanics was implemented to make exploration easier and the early development of the Arctic possible. In the Arctic, most oil and gas are extracted with the use of offshore drilling platforms. These massive structures need to not only withstand numerous loads, but also be subjected to harsh conditions. In order for this to be possible, development in its materials have had to be made. One example of these materials is steel. When steel gets cold, it can fracture with little to no plastic deformation in the material. This is the reason for the sinking of the Titanic, actually. The cold temperatures caused the hull steel to fracture easily when it hit the iceberg. Back in those days, this would happen to steel at a temperature around -2 degrees Celsius, which is what the sea was at that day. Although, today's steel is designed much better than it used to be. Now, it won't see that kind of degree of failure until it reaches below -60 degrees Celsius. Without this development in steel, offshore platforming in the Arctic would not be possible. With the increasing temperatures of the Arctic, new opportunities are appearing. The most profitable of those is within the oil industry. As the ice is melting away, there is more land that is becoming uncovered. Companies, in the future, will be able to set up rigs on the land to extract the oil and recover more products from the Arctic than ever before. Currently, most oil from the Arctic comes from offshore rigs. But having onshore wells will allow the industry to tap into a larger amount of natural resources that is locked away beneath the ice. Also, the increasing temperature in the Arctic would be able to help with the transportation of gas. Currently, antifreeze is used inside pipes to prevent blockages from frozen natural gas. With a warmer climate, these challenges will be less impactful. This will allow for an increase in the amount of natural resources extracted and the process to be efficient. Now we can see how mechanical engineering has played its role in the Arctic. First, with the exploration and the early development of the Arctic. Then, with the development of the oil and gas industry and the harsh climate that had to be overcome with materials such as steel. And finally, how a warmer climate is reducing the amount of challenges mechanical engineering needs to overcome. Well, thank you for watching my video, and I hope you have a great day, and take care. Thank you.